this end, let it be B. How the weight will act at the center? Mg will act, that is telling the weight, that one. It was only one inclined plane, no, the rod here, the two inclined planes we are bringing it. Okay, let me proceed. So this is the vertical. I'll draw a reference line because these are. So it's all about, I think, the geometry, no, nothing to do, because now you know torque idea. What is the torque? You know how to calculate the torque, and it will produce rotational effect. So you're quite familiar. It's all about now the application. You should be very good in the geometry. Nothing else is there here. So like this, I'll define. So this is the horizontal. We'll define it. I'm taking help of all the available geometry. So then perpendicular to incline. So let's take the how the normal contact should act. Perpendicular to incline. So the normal contact at B will be acting in this direction. Normal contact at B should be like this. And what about normal contact at A? And weight W will act vertically. I think at least if you are able to draw this much of diagram, I think you can carry on the thing. So this is NB. Now let's go for some measurement of angles here. So what can be this angle? This blue color line you further extend, 90 minus psi, this is phi, this is theta. Or see, getting confusion, theta 1, theta 2 also you can write it. Since question given, no, same angles I retained it. So this angle should be psi. And this angle is theta. So 90 minus psi plus theta. This angle should be. I'll magnify diagram. Some of you are okay.
Okay, sir.
See it clearly. Finish over. This will be theta. This should be the angle phi. And there's a normal reaction. And B I call this at point B. There's a normal reaction. This is the point B, no? This was A, we took it. NA, NB. Let's go for angle. This angle should be phi. So 90 minus phi. I think rest all everything you can manage here, no? Let's, so fine. So this is about the thing. Now, it's an equilibrium. So therefore, net force along x-axis, along y-axis should be 0. Then net torque about any point, not net torque about any point on the rigid body, it should be equal to 0. So this is the weight of the rod. Let's get into the so rough diagram. It is. So let's write equations now. Net force along x-axis should be 0. It's a purely mass-based problem, geometry-based problem. The physics concept is very less here. Along x-axis, net force should be 0. What are the forces that are acting along axis? Component of NB and NA here, no? So this NA, this will come. So I'll write it here. So this should be equal to NB sine phi, sine psi it is, minus NB cos of 90 minus phi. Cos of 90 minus phi should be sine phi. This is N here. Okay, fine. Yeah. Here I'm resolving this component. Or instead of this, directly there, y to this one, sine phi. It will make an angle phi with the vertical, horizontal component equal to this much. So call this is equal to 0. Call this equation 1. Let's come for here. Let's go for torque about point B. Net torque about point B. As the system is in equilibrium, net torque about point B should be 0. OL will set up torque due to weight and due to NA, that one. Due to weight, how much it should be? L by 2 cos theta. What is this length? This length is L by 2. What about this perpendicular length? L by 2 cos theta. So W L by 2 cos theta should be clockwise about point B. And then similarly go for torque due to normal contact NA, that one. So how to, we should take the perpendicular component. What is the angle made by normal reaction NA with the rod AB? I think this angle, no, 90 minus phi plus theta. It's vertical, it's like NA will act like this. A component of it perpendicular to rod, not along y-axis, perpendicular. So it will come somewhere here, no, perpendicular. Component of Na along the rod will be like this. Component of Na perpendicular to rod will be somewhere here in this direction. No, not along y-axis. I think you know enough geometry. So it will come somewhere here. So therefore this should be equal to NB, sorry, Na L sine of 90 minus phi plus theta. This should be equal to 0. This will be, we'll write it. Clockwise negative, NAL sine of 90 phi minus theta will make it. So this will be equal to 0. So WL by 2 cos theta plus NAL. Sine of 90 minus theta should be cos theta. So this should become NAL cos phi minus theta equal to 0. Okay, there's a one equation we got. So similarly, we'll try for torque about point A. So like why you are choosing A and B, I think that will be easier, no, mathematically. No, sir, I'm very good in mathematics. I'll choose some other point somewhere here. Yes, you do it. I'll choose about this. We don't have information of this length. Okay, of course, from that triangle, you can bring it. It's left to you. Net torque about A will say net torque about an axis passing through point. What is axis? Axis will be passing through point A perpendicular to plane of diagram. That's what we are defining it here. Now torque about A will go for it. So this is the equation 2. No, similarly, W into L by 2. It should be L by 2 cos theta. It should be anti-clockwise. Next, NB, component of NB, no? Again, similarly, come for this. Component of this perpendicular to the rod. NB will act like this. Its component perpendicular to the rod will be somewhere here in this direction. So this should be equal to NB L. Okay, again solving this should be WL by 2, and this particular torque is clockwise, all set equal to 0. Anti-clockwise we took positive, WL by 2 cos theta, this will be negative. NBL sine of 90 minus theta will be cos theta. L will get eliminated. Solving 1, 2, 3. So first what will happen? So we'll get expression for NA. So I'll do one thing. I'll solve for NA. What should be the NA value? W cos theta by 2 cos psi minus theta. What is NB value? NB value will be W cos theta by 2 call this equation 2 and 3. Substitute equation 2 and 3 in 1. So we'll get a relationship between the theta. Okay, I think it's all about mathematics, no? There's no much basic physics concept. I'll write it. So I'll write down the answer. Later on you verify it. It's a pure mathematics one after this. Trigonometry. Just bring back your some trigonometry ideas here. Put 2. 1. So we'll get this as tan theta is equal to this will be your answer.